Hi guys, and welcome back to another Algebra 1 lesson. Today's lesson is Unit 2, Lesson 5. We are continuing in our study of inequalities, and we're going to add a special one that is a way of linking two inequalities together, and it's called a compound inequality. And specifically, the one that we're going to look at in today's lesson is an OR compound inequality. And in the next lesson, we'll end up looking at an AND version of this. So our objectives for today is I can solve compound OR inequalities, and I can graph a compound OR inequality. And so let's just think about what an inequality is to begin with. So say we have a simple inequality. This is what you've already learned. And so we could have an answer like this after we've solved it, where x is greater than 5. But what if there were two possible conditions where you could have answers? So it would be just like a regular English sentence where we could say, would you rather have steak or would you rather have shrimp? You know, it could be either or, and both of those are possible answers. We can do the same thing with inequalities, and we call those compound inequalities. So if we have two simple inequalities that are combined into one, and over here it says statement. For example, we could have a compound inequality like this, where maybe we could have the solution is anything where it's x is greater than 5, or the solution could be anywhere where it's x is less than -1. So you would have two ranges of numbers that could be true, but the numbers that are in between those would not work as a solution for either one. And you'll see what I mean when we go graph. We're going to still follow the same rules where open circles are going to mean a less than or a greater than inequality. And a closed circle is going to mean like a less than or equals, or a greater than or equals, as long as it's got the equal sign in it. You'll use a closed circle. And of course, that closed circle means that the answer includes that number itself. So in OR inequality, the solution can be either inequality. And I accidentally misspelled that. Don't spell inequality like I did. Let's see, try again. Inequality. There we go. So let's look at this first example. And so we're given a compound inequality here where it says solve, and we have this inequality here, or this inequality. And then we're going to graph the solution. Okay, so the way that this is going to work is I'm going to take this first inequality that's over here on my left, and I'll just go ahead and write it here. And so I've got 3y minus 5 is less than -8. So I can solve this one, and I'll come back to that in just a second. But I'm going to take this other part here, and I'm going to solve it over here. So this is 2y minus 1 is greater than 5. Alrighty, so it's like two problems in one. Let's go ahead and I'll solve this pink one first. So 2y minus 1, I'm going to move my 1 over. So I'm going to add 1 to both sides. And then we have 2y is greater than 6. My 2 is touching my y, so it's a multiplication. So to undo that, I'm going to divide by 2. And we get y is greater than 3. Okay, so this is one possible solution to it. We can come over here and graph it. So this is going to have an open circle at 3, and the solution is going to be going this way. Okay, well, let's go solve this blue one. Okay, so my 3y minus 5, I'm going to move my 5 over to the right-hand side. This cancels, and I get 3y is less than -3. And I'm going to divide by 3. and divide by 3. And I get y is less than -1. So to graph that one, I'm going to come over here to my -1, and it's an open circle kind because it doesn't have the equal bar in it. And the way this one is true is this way. So any number can be an answer to this compound inequality if the answer is, let's see. So it could be y is less than -1 or y is greater than 3. Okay, if it falls into either one of those ranges, it's the answer. Notice what is not the answer. The answer, like all this right here, this is not the answer. Okay, and then the number themselves, because they're both open circles. So like exactly 3 is not the answer, and exactly -1 is not the answer either. So that is the narrow range of where it isn't an answer. Every other number in the entire real number system is a possible answer with the way this is shaded. Okay, this one is changing it up a little bit. It's asking you to reflect on this graph that you see here. So it says, write the compound identity for this graph. We're just going to break it up into 2 chunks. We have a chunk right here, and we have a chunk right here. And then the compound identity is both of them together. So how would we do that? Well, let's think about this chunk over here. Oops. Every lesson I have to write in the wrong thing at least one time. Okay, so let's look at this one over here. So I can see this is at -6. So I got -6. And the number going this way, any answer that is possible, it's going to be less than. Okay, x is less than -6 going this way. So that's one answer. And then over here, it's starting at number 2. So I'm going to write down my 2. It is a closed-in circle so that I know it's going to have the equal sign in it. So any number going this way, it's going to be x is greater than or equal to 2. Okay, so all the numbers going this way could be a possible answer. The numbers that are not an answer are anything falling into here. Okay, so we could write this together. We could write it closer together. The compound identity is x is less than -6 or x is greater than 2. Okay. This one is also asking us to write a compound identity for this graph. And I'm just going to break it up into 2 halves. I've got this half here, and I've got this half here. Okay, so we'll write our statement for this one, and we'll write it for this one. So let's do this. Okay, so I'll do my blue one on my left. So this number here is a -7. So I've got -7, and my x is going to be less than -7, but it's got a filled in circle. So it's also going to have an equal sign. Okay, x is less than or equal to -7. And then we can do the same thing over here with this one. And I'll write that in pink. So this number is at -4. So I can write down my -4, and my x is going to be anything bigger than -4 or equal to it because it's got a filled in circle. So my compound identity is that right there. X is less than or equal to -7, or x is greater than or equal to -4. So any number that falls into this little tiny range right here would not be an answer to this compound inequality. Alrighty, example 4. So we've got solve this one or this one, and then we're going to graph the solution. So how we do that when we've got 2 problems is we're going to solve this problem and we're going to solve this problem second. And then we'll graph each one of them independently. So I'm just going to label this number 1 just to kind of color coordinate it here. So I've got 4n plus 3 is less than or equal to negative 5. So I'm just going to rearrange like we have done all of our equations and inequalities so far. We're going to subtract 3 from both sides. Bring down 4n, less than or equal to 5. Oh wait, negative 5 minus 3. See, I almost did that where I've lost my negative somehow. Don't do that. It's easy to lose a negative, right? We're going to divide by 4 on both sides. And so I get n is less than or equal to negative 2. So that's 1/2 of my inequality. So I'm going to come over here to negative 2, and I need to fill in my circle, and we'll see if this thing is going to erase it in my, oh, it kept it. And so all the numbers in this direction are a possible answer. Okay, let's go solve the other one. So my second one is this guy here. So we get n minus 8 is greater than negative 1. I add my 8 to both sides, and I get n is greater than 7. Alrighty, we can do that. We see that there's no equal sign in it. It's just a greater than. So I'm going to do an open circle, and all the answers in this direction are possible. Okay, so anything that falls in between those cannot be an answer, but everything over here on the left-hand side, possible answer, going to negative infinity. Everything over here on the right-hand side is going to be a possible answer, going to positive infinity. So if we, wrote this like as one statement together, we could say n is less than or equal to negative 2, or n is greater than 7. Alrighty, so we have our last example here. We've got solve where we've got this guy or this guy, and then we're going to graph the solution. So let's do this. Okay, I'm going to solve this one in blue because that's just the color that I'm choosing for whatever reason. So I got 2p plus 1 is less than negative 7. So I'm going to subtract my 1 from both sides. I get 2p is less than negative 7 minus 1 is negative 8. I divide by my 2, and I get p is less than negative 4. So I don't have the equal bar in it, so I'm just going to use an open circle, and every number going to the left is a possible solution. Let's solve the second one. We end up with 3 minus 2p is less than or equal to negative 1. I'm going to move my 3 over by subtracting it. So that cancels, and we get negative 2p less than or equal to negative 4. I'm going to divide by negative 2, divide by negative 2. Now, I almost forgot. Look, we have a negative here, so we're dividing by a negative. So we got to do something here with this sign, right? So I've got p. We got to flip our sign. Greater than or equal to 2. So I'm going to come over here to 2. It is a filled in circle because it's got the equal bar in it, and every number going this way is a possible answer. Okay, so we could write it all together just kind of in one statement. P is less than 4, or P is greater than 2. So in answer to this particular inequality, a solution can be any number in between these points, and it also includes this negative 4 exactly, right? So anywhere from negative 4 all the way up to 1.9999999. Okay, everything else would be a solution. I hope that helps, guys. Until next time, bye.